Hi everyone, today we're recording our part 3 presentation for Parkinson's disease for you to watch asynchronously, and we're going to be discussing the paper we assigned, treatment options for motor and non-motor symptoms of Parkinson's disease. And yeah, let's just get started.
Perfect. So the first question we want to address is why focus on treatments for Parkinson's disease specifically. And it is the second most common neurodegenerative disease besides Alzheimer's, which we learned about last week in their part 3 presentation. And it has a prevalence of 41 people per every 100,000 in the fourth decade of life. And by the eighth decade of life, it actually scales up over 50 times in prevalence to 1,900 people per every 100,000. In the United States, there's estimated 1 million citizens who are currently living with Parkinson's disease, and approximately 10 million people living with it worldwide. And then in the US, there's approximately 60,000 new cases every year in the US. And so if you look at the bottom here, you have a really interesting graph that tracks the prevalence of Parkinson's disease over the past 45 years, or ever since 1975. And as you can see in that far left, the prevalence has almost doubled since the initial data was collected in 1975. And if you look on the right, that increase is primarily attributed to males over the age of 70. And so if you think back to the first part of our Parkinson's disease presentation, we thought about how various environmental factors could possibly play a role in Parkinson's disease. And while the authors of this research didn't necessarily look into or explain too many environmental factors, one thing to consider is that smoking was associated with a lower chance of Parkinson's disease. And so as a lot of us know, smoking prevalence has also declined ever since 1975. And so that could possibly be one example of how environmental factors do impact the prevalence of Parkinson's disease. Now, with Parkinson's disease treatments, there are going to be three main categories of challenges that you will run into. The first is that approximately 85 of the cases are sporadic, and the etiology remains elusive of those. A lot of thoughts behind possible etiological causes are oxidative stress, neuroinflammation, immune system dysfunction, and other things along that manner, but still relatively unknown. And then on the flip side of that coin, you only have 10 or 15% of cases that are familial and associated with specific genes, such as the SNCA, alpha-synuclein gene we talked about, LRRK2 and PINK1. And so in these cases, there might be some actionable target or a specific gene product that you can definitely look at for treatments. However, that's only going to be 10 to 15% of cases. The next big challenge is going to be that there are both motor symptoms and non-motor symptoms associated with Parkinson's disease. And because the etiology of the neurodegeneration of Parkinson's is not necessarily known, it's very difficult, if not impossible, to address all of these various symptoms with one specific treatment. And then finally, it's very tough to measure the progress and the efficacy of various treatments with Parkinson's. Neurologists attempt to do this through various scans to evaluate clinical progress or neurodegeneration in the brain. There's also the Unified Parkinson's Disease Rating Scale, which was developed in 1987 to really set a standard for how you measure Parkinson's disease. And there's going to be four assessments that go into this UPDRS. The first is assessment of mentation, behavior, and mood. There's going to be an assessment of motor ability, and then another assessment of the activities that you can do in your daily lives. And then the final part of this rating scale is going to be any complications that a patient does run into therapies. So before you get to treatments, you obviously need to be diagnosed first. So I'm going to pass it along to Cate, who will go into a little bit more about the diagnosis for a refresher.
So we have mentioned some of these diagnostic criteria in our earlier presentations, but it is worthwhile to review in the context of treatment and management of symptoms, because diagnosis is really what's required before you can move forward with mitigating the symptoms and maintaining as much function as possible as the disease progresses. So for a probable Parkinson's diagnosis, a patient must express at least two of the following symptoms, and that's resting tremors, bradykinesia, rigidity, and postural instability. And then to confirm this diagnosis, several scans can be used to rule out other potential causes, such as a CT scan being used to rule out vascular disease or a tumor. DAT scan, SPECT scan takes a look at dopamine cells, which, because Parkinson's disease affects dopaminergic neurons, is helpful. So that's that figure on the top right is an example of this kind of scan. And then MRI is more general brain tissue imaging. And then to have a confirmed diagnosis, a histopathological assessment must come back positive with the presence of alpha-synuclein Lewy bodies, which is the pathological hallmark of Parkinson's disease. And that you can see Lewy bodies in that purple figure on the bottom.
All right, so according to the Church article that we assigned you guys, there are 5 main approaches to treatment. These include rehabilitation, therapy, restorative treatment, maintenance, and finally surgery. And we'll be touching on these strategies as we progress through the presentation. The first strategy is rehabilitate, and logically one of the first steps in Parkinson's disease treatment is to seek out consultation with a physical therapist, occupational therapist, or speech pathology therapist. And the goal is to begin management of some of the altered motor symptoms in Parkinson's disease patients. Some common treatments when meeting with these professionals include LVST loud and LVST big, which aim to rehabilitate both voice and body by encouraging louder speech and bigger movements. And we have a video example of this here.
LVST big is an exercise program developed for people with Parkinson's to stop the negative changes that happens in one's body, or to some extent reverse the changes that have already happened. I'm here to learn how to fight Parkinson's. And some of the main concepts are high intensity, which requires a lot of effort from the patient. Okay. Amplitude, which is increasing the way you move and speak and your range of motion. And calibration, that your brain starts to recognize when I move like this, when I move the way my therapist says I'm supposed to move, that is more like normal movement than movements normal of a person with Parkinson's.
All right, so as we've learned, medication therapy is the most mainstream approach to Parkinson's disease treatment. Unfortunately, up until this point, current medications can only help to mitigate symptoms. None thus far have been able to treat or reverse any of the neurodegeneration that comes with the disease. All of the medications aim to increase striatal dopamine levels in hopes of alleviating some of the associated motor defects that we've talked about. This sort of medication therapy, though, loses efficacy over time, resulting in dyskinesia. And the most common subcategories of Parkinson's disease medication, as we can see on the bottom of this slide here, include dopamine precursors, dopamine agonists, MAO-B inhibitors, and COMT inhibitors as well.
So before we dive into those specific categories, I just want to do a quick review over the etiology of the movement motor pathways that are affected by Parkinson's disease, because it is these pathways that are primarily targeted by these various medications. So just a quick review, the main area of the brain that causes the dopaminergic death happens in the substantia nigra pars compacta, which is the area pointed at the screen by the yellow arrows that produces dopamine. And that dopamine is going to either the excitatory or inhibitory pathway of movements and going to the striatum, where the dopamine receptors in the striatum continue on neurotransmitter cascade that ultimately either inhibits or excites your various movements. As you can see in the direct pathway or the excitatory pathway, the primary dopamine receptor families are called D1 receptors, and in the inhibitory one, you have D2 receptors. So these will be important as we get into some of the further treatment options that we'll get into right now.
Okay, so as we've seen, the most commonly seen medication strategy are dopamine precursors. In fact, carbidopa, levodopa is an example of a dopamine precursor. And in this treatment strategy, levodopa is biosynthetically transformed into dopamine. And it's usually used in conjunction with carbidopa, which provides relief to most adverse side effects. But most importantly, the carbidopa prevents levodopa from metabolizing in the periphery and helps it to cross the blood-brain barrier. And as we touched on earlier, this medicinal approach loses efficacy over time.
The next type of medications are dopamine agonists, and dopamine agonists act on the dopamine receptors, and without actually being dopamine, they imitate the effects of dopamine to cause the cascade from the receptors onward without actually having dopamine itself active. And so there are 5 main approved therapies by the FDA currently, which can be seen in the structural form and the top right figure there. And dopamine agonists are most effective and act on the D2-like receptors. So if you go back to 2 slides ago and think about that, that's primarily going to be in the indirect or inhibitory motor pathway. However, with a lot of these dopamine agonists, some people experience impulse control orders such as excessive shopping, pathologic gambling, and hypersexuality. And this really emphasizes and highlights how a lot of the neurotransmitters in the brain are very complex processes. So in addition to dopamine being part of the movement pathway, it's also very central to the reward pathway and pleasure pathway, where as opposed to being part of the substantia nigra pars compacta, dopamine is also released out of the ventral tegmental area of the midbrain as well as part of that reward and pleasure pathway. So just something to keep in mind and a great little snippet there.
As we mentioned earlier, 2 other medicine therapies include MAOB inhibitors and COMT inhibitors. MAOB stands for monoamine oxidase beta, and it's an enzyme that activates dopamine by inhibiting this enzyme, we can decrease dopamine metabolism, which would in turn increase dopamine concentration in the brain. This medication is often used in tandem with a levodopa supplement to increase efficacy. And 2 examples of these include salicyline and rasagiline. COMT stands for catechol O-methyltransferase, and its function is to process levodopa into 3-O-methyldopa, and by inhibiting this which prolongs its ability to create dopamine.
And finally, we have anticholinergics, which is a class of drugs that blocks the activity of acetylcholine, a neurotransmitter involved in the regulation of movement. And some examples of anticholinergics are benzotropine and trihexyphenidyl. So therapies for non-motor symptoms of Parkinson's disease are varied and specific to each of the non-motor symptoms, because as you see in that table on the right, there is a wide variety from depression and anxiety to sleeping disorders to drooling. So depression occurs in up to 50% of persons with Parkinson's disease during their disorder. And additionally, there's a high incidence of anxiety in the form of worry, panic, unease, and jitteriness. And it can be challenging for a physician to determine if it's warranting a standalone diagnosis or if it's occurring as a symptom of Parkinson's disease. But regardless, these are typically treated with standard antidepressants and anti-anxiety medications, such as SSRIs, SNRIs, and psychotherapy. And that table on the right also illustrates how many FDA-approved non-motor symptom drugs there are for non-motor symptoms on the market. And as you can see, there appears to be good options.
So the next segment of those 5 treatments is going to be restorative treatments, specifically if there are any neuroprotective drugs for Parkinson's disease. So anything that will preserve the brain and the neurological functions and cells of it. And the answer is no. However, with 2 of the MAO-B inhibitors that Alyna had previously talked about with selaginline and rasagiline, there was the potential, and there were a few studies that showed that in mouse models that they were neuroprotective. And so this incited 3 human studies that are listed in the bottom left called DataTop, Tempo, and Adagio. And these studies came back very inconclusive. And because of that, the FDA did not give these companies that were producing these 2 MAO-B inhibitors to be able to label them as neuroprotective. So while they do have symptomatic relief for Parkinson's patients, they actually are unable to stop the neurodegeneration that is actually occurring.
So in considering exercise in the context of restoration and maintenance of Parkinson's disease, it is believed that exercise and physical activity mitigate current neuroinflammation and may even offer neuroprotection. And in studies of a mouse model of Parkinson's disease, it was found that exercise preserved the remaining dopaminergic neurons while increasing brain-derived neurotropic factors and reducing pro-inflammatory markers. And other results that have shown that strenuous aerobic exercise offers neuroprotection in Parkinson's disease by way of inhibiting alpha-synuclein accumulation. Other animal studies have suggested that strenuous aerobic exercise promotes antioxidation and anti-inflammatory properties, both in the brain and systemically.
So how exactly exercise has these restorative and possibly maintenance effects on Parkinson's is not completely understood, but there are some research into potential mechanisms by which it might occur. So going back to our favorite mouse model, studies have shown that when mice are go through anaerobic exercises and are pushed, they show an increased expression of interleukin 13. So a quick update on interleukin 13. It's found on the long arm of the 5th chromosome, and it's an immunoregulatory cytokine that regulates the function of human B cells and monocytes. And so how exactly does exercise increase interleukin 13 perhaps be neuroprotective? And so a study in 2016 found that interleukin 13 actually redirects mitoglial and infiltrating macrophages to convert a pro-inflammatory environment towards one of an anti-inflammatory environment. And so to tie things kind of full circle, if you think back to our part 2 presentation on that primary research, they noticed that there was an increase in nitrated alpha-synuclein in Parkinson's patients. And then they hypothesized that the nitrated anti-synuclein potentially activates microglia to produce inflammatory mediators, and that inflammatory environment was ultimately what led to dopaminergic neuron death. And so if the potential for interleukin 13 to instead create an anti-inflammatory environment, this might be one way by which exercise can potentially cause maintenance and restorative and slow neurodegeneration.
All right, so building off of exercise is a form of maintenance. Maintenance is important as a treatment strategy because there are no known medicine therapies that are able to slow the progression of Parkinson's disease, as we've mentioned. So often patients turn to complementary and alternative medicine, CAM. They do this with the hopes of preserving their remaining dopaminergic neurons and reducing neuroinflammation, as Cate mentioned earlier. Recently, there's been an increased interest in vitamin D as a part of this maintenance, and it's been found that patients with deficiencies in vitamin D3 have had impaired motor function and increased disease severity, while patients with higher levels of vitamin D3 have had better cognitive performances. Additionally, magnesium L-threonate has also been of interest. It's been shown to cross the blood-brain barrier and may assist dopaminergic cell survival. Vitamin B1 supports cognition and helps with nerve health, so that's also been an area of interest for CAM. And finally, taurine aims to prevent neuroinflammation by down-regulating pro-inflammatory microglial cells.
So a few more of those CAM treatments, specifically relating to oxidative stress, are out there. So if you call back to our previous presentations, you'll recall that the metabolism of dopamine produces a lot of various byproducts that can cause quite a bit of oxidative stress when dopamine is not handled through the proper mechanisms of the cell. And you'll also recall that in a few of the genetic Parkinson's caused diseases, that the mitochondria are processed improperly. And so mitochondria that are faulty and should be tagged for recycling are not done so. And so because of these two various mechanisms of causing oxidative stress, which may lead to neuronal death, there are a few substances out there that counteract this. One would be curcumin, which has been shown to decrease the MAPK and NF-kappa beta molecules. And so these two molecules are shown to be part of a pro-inflammatory response. So once again, the inflammation could be a possible reason for dopaminergic death. You also have N-acetyl-L-carnitine, which has been shown to increase mitochondrial function and even restore some lost mitochondria deficits if there are out there. This is very effective for PARK2 and PARK6, which, if you recall back, once again, have to do with genetic malfunctions in the recycling of mitochondria. And then the final CAM option is going to be N-acetylcysteine, which produces which is a building block for the antioxidant glutathione, which can help prevent oxidative stress further as well.
All right, so the final treatment strategy we want to touch on is surgery. I know a lot of you guys asked in your reading reviews about this deep brain stimulation. And this deep brain stimulation is considered as a treatment for patients that did not find success with medication. The purpose is to control tremors and shaking, but again, this treatment, like current medications, is not able to slow the progression of neurodegeneration. Essentially what happens are electrodes are inserted into the brain using MRI and recordings of brain cell activity during the procedure, and then in a second procedure, an impulse generator battery, essentially a pacemaker, is inserted under the collarbone. The DBS targets areas of the brain that play a role in movement, such as the thalamus, the subthalamic nucleus, and the globus pallidus. And the mechanisms by which DBS is successful is not quite understood yet, but people have called this surgery the most important advancement in Parkinson's disease treatment since levodopa.
So in a lot of the reading responses, there are questions about that deep brain surgery. And specifically, I think where the confusion happened was that in a lot of the medications that we previously talked about, we talked about specifically targeting that dopamine pathway coming from the substantia nigra pars compacta. And however, as Alyna had previously talked about, that area of the brain is not the main focus of deep brain surgery. Instead, it's these other areas of the movement pathway, the thalamus and the globus pallidus, that you can see pointed to by the yellow arrows there. So I just wanted to clarify that deep brain surgery still does have a mechanism of influencing the motor movement pathway, even though it's not directly related to dopamine. And so we have a cool video about deep brain surgery in a patient that had actually gone through it.
I was scared. And it was a quite emotional time. You don't know what your future's going to be like because you see yourself losing your physical capability.
Mike has tremor predominant Parkinson's disease, and his tremors were significant. He had said, I can't button my shirt. I haven't buttoned my shirt in years. All these normal everyday things that we are used to doing, Mike couldn't do because of his tremors.
DBS stands for deep brain stimulation, and basically in a nutshell what it is, it's a pacemaker for the brain, just like a pacemaker for the heart. So patients with Parkinson's disease may consider deep brain stimulation if they have symptoms that are not well treated with the medications, if the tremors that they have are not well controlled with medications, or if they're having a lot of stiffness and slowness of movement, then DBS is a really good choice to consider.
As time went on, I saw how it was deteriorating. So that to keep working, I've got to be able to do something, to stop this degradation of my system. And had that done in August, and then come October of 2017, it turned on. That's quite an experience.
When I first turned it on, we started to first get tremor control. That's the easiest thing to see. It's like, oh, okay, his tremor's not there anymore. Do you feel it going on?
Yeah. It's amazing.
I bet.
It was like chains when the rubber just came off. I didn't move. I could button my shirt. I hadn't worn a shirt that had buttons on all the way down for like 5 years. I couldn't button the shirt.
He went over and looked in the mirror and buttoned his shirt up and down, and he just kept doing it over and over again. And he couldn't believe he could button his shirt.
Deep brain stimulation has really been a game changer in the treatment of Parkinson's patients. And so it's a therapy that we really believe in. Movement disorders we typically treat with DBS include Parkinson's disease, essential tremor, dystonia, and then also Tourette's.
Everything was just fabulous after getting DBS.
And the other, yep, we got to move it around to make it see exactly what's happening.
It was a miracle.
So quite a cool video there, especially when they turn it on, his tremors instantly stabilize. So a great story there and a great option for those with Parkinson's disease.
So moving forward, while the deep brain stimulation is great for treatment, as we saw, and there are several medications, it would be very valuable, as we discussed earlier, in the importance of continuing to focus on developing new treatments or potentially repurposing other treatments. So here we have ongoing clinical trials as of July 2020. So 145 registered trials across phases 1, 2, and 3, 88 of which are focused on symptomatic relief, 50 of which are testing repurposed therapies, and 57 are aimed at long-term disease-modifying therapies. And some examples are exenatine, a glucagon-like peptide-1 receptor, which reduces glucose in type 2 diabetes. And the big focus here is discovering if the efficacy can be proven in Parkinson's disease patients, and also glial cell-derived neurotrophic factor, so survival promoting molecule for dopaminergic neurons from striatal astrocytes. And the focus in this area is determining how best to administer this molecule and if there are other neurological impacts if it is used for treatment. And the exact function of GCNF is not completely understood, which is concerning to some and really drives home the point of why more research is needed and why this field is deserving of funding and resources.
And so other ongoing clinical trials specifically related to stem cells, which I know a few of you had questions on your reading responses, there's two main ones that are going on with embryonic stem cell studies, which are occurring in China and Australia. And so from these, they're taking embryonic stem cells developed in fetal midbrain tissues to develop new dopamine neurons. And these are actually transplanted directly into the patient's forebrain in order to replace those dopaminergic neurons. Another study is going on in Japan, which is focused on induced pluripotent stem cells. And so what this is that adult blood cells and skin cells are reprogrammed back into their embryonic-like pluripotent state, where they can then be programmed to create a variety of cells for whatever needed therapeutic purpose there is. And so in this specific study, these group of researchers have developed and have shown that they can produce dopamine progenitors derived from human induced pluripotent stem cell studies. And then in vitro, they confirm that they can make these dopamine progenitors take on the dopaminergic characteristics that would be needed to help a patient in Parkinson's. A big concern with these induced pluripotent stem cells is that they sometimes might not completely differentiate into the cells that you want them to, and might differentiate into other things. And there's also the issue that when you are reprogramming these various cells so many different times, that they may have an association to develop cancer more likely. However, this group of researchers has also demonstrated that their methods completely differentiate into dopaminergic cells, and there's no association with cancer as well. So they moved on and actually tried this in a mouse model, once again, returning to that mouse model, and showed that the induced pluripotent stem cells actually did improve the behavior and were safe in Parkinson-like deficient mice. And so in 2018, they actually started up a human trial with these various methods, which is still ongoing today. And I'm sure we'll have the results in the upcoming months or upcoming years, which will be quite exciting.
So at this point in a typical presentation, we would love to have a discussion, but since we're recording this ahead of time, we were thinking we could just offer some questions to consider, and next time we're all in class together, if we have time, we could come back and discuss them. So we'd like to think about, should clinical trials focusing on symptomatic relief or long-term modifying therapies be given priority? Why might the prevalence of Parkinson's disease be increasing over previous decades? And where should the future of Parkinson's research head? Therapies, understanding etiology, better screening methods, improved ways to track progression, or if you can think of any other areas.
And then to continue just a little bit more engagement, we will link a survey, which we can briefly discuss next time. The survey will have an area if you have any outstanding questions that we can address before wrapping up our final talk on Parkinson's disease. And that will be linked to this presentation here. And so here are the additional resources we use in addition to the ones cited on the slides. And that concludes our Parkinson's Part 3 presentation. Thank you for listening along all this time and for the past 3 presentations.